Hello viewers, in today's session we are going to discuss another important and very conceptual problem from definite integrals. And in this session we'll solve this problem where we are given a function f which is given to be differentiable function, and this function f of x, it satisfies this relation, that is f of x is equal to square root of 3 over 2 plus integral 0 to x square root of 1 minus f square u du, right? So here we have the function that is the square of the function f of u, and then we have to find f of pi, right? So let us see how easily we can solve this problem by using the concept of uh, derivatives and one important property of definite integrals. So let us start. So here we are given this relation, right? Now what we will do, we'll differentiate both sides with respect to x. So we'll write dy dx of f of x, and here the derivative of root 3 over 2 is 0 because it is a constant, and then we have d by dx of 0 to x and square root of 1 minus f square u and du, right? So dy dx of f of x is simply f prime of x, and here d by dx of this integral is simply equal to square root of 1 minus f square x. That is, we'll replace this u by x. So here we have used an important result from definite integrals, which says that if we have a function, say y is equal to the integral from a to x, and here we have say g of u du, then the derivative of y with respect to x is simply g of x, right? So if we compare this integral with this one, then the lower limit is a is equal to 0. Here a is a constant, and x, here the upper limit is x, here also the upper limit is x, and g of u is given by square root of 1 minus f square u, right? So when we find out the derivative of this integral with respect to x, then we simply replace this u by x. So we have now f prime of x is equal to square root of 1 minus square of the function, that is f of x. And now this is a differential equation of first order and first degree. So now we have to solve this differential equation to get the value of f of x. So now to solve this differential equation, let us write f of x as simply f, just for convenience, right? And f prime of x as df over dx. So we'll use these notations just for convenience. So f prime of x can be written as simply a df over dx, and here we have square root of 1 minus f square, right? So separating the variables, because this differential equation is variable separable form, right? So we can separate the variables. So we have df over square root of 1 minus f square, and here we have dx. Now integrating both sides with respect to here we have x, and c is the constant of integration, right? Now this is a well-known integral, because we know that integral dx over square root of 1 minus x square is equal to sine inverse x. So now the integral of df over square root of 1 minus f square is simply a sine inverse of f, right? And in the right hand side we have simply x, integral of dx is x, and c is the constant of integration, right? So now we can write f is equal to sine of x plus c, right? So now again using the usual notation for f as f of x, we can now write f of x is equal to a sine of x plus c. So this is the form of the function f of x, and we can see that f of x is a sine function. Now our next aim is to get the value of this constant of integration c, right? So let us find out this c with the help of some condition. So now let us take x is equal to 0 in the given equation, right? So when we take x is equal to 0 in this equation, we have f of 0 is equal to square root of 3 over 2 integral 0 to 0, and here we have square root of 1 minus f square u and du. Now clearly this term is 0 because here both the limits of integration are 0. So we are simply left with f of 0 is equal to square root of 3 over 2. Now let us use this condition to get the value of c, right? So what we will do, we'll take x is equal to 0, and f of 0 is equal to square root of 3 over 2 in this equation. So we have sine inverse f is given by square root of 3 over 2, and x is 0, and here we have c. So we have c is equal to sine inverse square root of 3 over 2, which is equal to pi over 3, right? So sine 60 degrees, that is sine pi by 3, is equal to square root of 3 over 2. So the value of constant of integration c is equal to pi by 3. So let us take this value in this relation. We have f of x is equal to sine of x plus pi by 3, right? So this is our required function f of x, and let us find out the value of f of pi by taking x is equal to pi, right? So we have f of pi is equal to sine pi plus pi by 3, right? And sine pi plus pi by 3 is minus sine pi by 3, because we know that sine pi plus theta is equal to a minus sine theta. Now sine pi by 3 is root 3 over 2, and here we have the negative sign, right? So the value of f of pi is given by minus square root of 3 over 2. Now here it is important to note that while calculating the value of the constant of integration c, we have taken x is equal to 0, and f of 0 is equal to square root of 3 over 2, right? And if we take x is equal to 0 in this equation, then we have f of 0 is equal to sine 0 plus c, that is simply equal to sine c, and f of 0 is root 3 over 2. So here we have root 3 over 2 is equal to sine c, right? And root 3 over 2 is equal to sine pi by 3, and we have now this equation, that is the trigonometric equation, sine c is equal to sine pi by 3, right? So if we use the concept of general solution of this differential equation, this trigonometric equation, then we can write c is equal to n pi plus minus 1 raised to n, and here we have pi over 3, right? So if we take the general solution and we have to find out some other values of c, then we can also make use of the concept of general solution of this trigonometric equation. So in that case, c is given by n pi plus minus 1 raised to n pi by 3. So in the present case, we have just considered the value of c corresponding to n is equal to 0. So when we take n is equal to 0 in this general solution, then the value of c is simply given by pi by 3, right? And in that case, the form of the function f of x is given by sine x plus pi by 3. So, to summarize this discussion, we can easily conclude that as per the requirement of the given problem, we can use the different values of C from this general solution. Right, so assigning different values to n, we can obtain different values of this constant of integration c, and accordingly the form of the function f of x can be taken. So in the present case, we have just taken n is equal to 0, and corresponding to n is equal to 0, we have c is equal to pi by 3, and our function is given by f of x is equal to sine x plus pi by 3. So accordingly, using this relation, we have calculated the value of f of pi.